Good evening, everybody, and welcome to tonight's edition of the Triangle Area SQL Server User Group's main meeting. So tonight we have with us Jared Poche, who is going to talk to us about making every millisecond count and a little bit of performance tuning and optimization. So Jared, please take it away.
All right, thanks very much, Kevin. So, this is Every Millisecond Counts, a case study in tuning a frequently run procedure to less than 1 millisecond in duration. My name is Jared Poche. I am a database engineer for ChannelAdvisor, so I've had the pleasure of working with Kevin for several years now. I've got my contact information here if you want to check out my blog or send me a tweet afterwards and with any questions you might have. I've been working with SQL Server for 20 years now, which sounds really strange to say. Um, I am a 10-year veteran of Microsoft. I was working in Microsoft support in Charlotte for 10 years. I've been blogging for the last several years, speaking at SQL Saturday events when I can, and I have spoken at Virtual Pass the last 2 years, and I'll be speaking in Seattle again this year. So this talk is about tuning one specific stored procedure. This is kind of an intermediate to advanced level topic. I wanted to do a presentation about it because I felt it was very much not standard query tuning. It wasn't anything obvious that we could work on here. This is a procedure that's been worked on before. There were no missing indexes. There were no table scans or anything else really obvious. So the goals here is I wanted to show uh, the attention to detail we had to have to find the opportunities in this one. Hoping that you'll learn a new code technique or two. And I want to encourage you to understand how things work outside of the database because that was very key for us improving the performance of this procedure. So, foundations and topics. There's a number of things that come up in the course of this, so I'm going to go ahead and define some things just so we're all at a good starting off point. So first, the procedure that we're working on is an upsert procedure. It's attempting to either update rows or if they don't exist, to insert those rows into the table. So that's fundamentally what we're trying to do. We're trying to insert or update some data in one specific table. We use a lot of table variables. Now, table variables, I feel like mainly when I'm reading a blog post and somebody is talking about table variables in SQL Server, they're typically saying don't use them. And the big thing that comes up is that table variables don't have statistics. So compared to say a temp table, the optimizer is typically able to come up with better plans for a temp table than it is for a table variable because it always assumes the table variable only has one row in it. Now, if you're in SQL Server 2019 or later, there are some features that can improve on that behavior. But we use table variables for a couple of reasons. One is table valued parameters. Table valued parameters allow you to pass in essentially a small table of data as input to a given procedure. They're very effective for allowing you to do processes that insert or update multiple records while providing all of the information for all of those records. And in addition, you can have memory optimized table variables. Now, memory optimized table variables are really beneficial because table variables like temp tables are objects that actually get created in tempdb. So one of the problems with temp tables is running in with tempdb contention if you're creating too many objects in tempdb. And there's many a blog post about that. Well, table variables have that run into tempdb contention too, unless they're memory optimized, in which case we get to sidestep that. And giving the number of stored procedures that we run in ChannelAdvisor on a daily basis, being able to skip that contention is a huge benefit. Table spools. So there was a table spool that came up at one point when I was working on this, and it was one of the things that made me refocus on the execution plan I was looking at. Uh, Table spools are a thing that SQL Server will create to take an internal result set and basically stash a copy of it so that it can refer back to that information multiple times later on. You'll see these sometimes just when we're updating indexes, but they're also used for other purposes. Um, uh, Especially like with eager spools and another topic that we'll talk about in a moment. I tend to see a table spool though and think that we're probably doing more work than we need to be doing. So I want to make sure I understand why we're spooling up those results and then referring to them multiple times later on. Indexed views also come up. So a view is relatively straightforward. A view is really just a predefined query that's gathering information from multiple sources. But an indexed view is a lot like a separate table where the data is actually being stored somewhere now. I saw somebody comment to Brent Ozar on Twitter that an indexed view is really just a separate table populated by a trigger, and I thought it was a funny perspective on that and not entirely inaccurate. So I had an indexed view that came up at one point, and I had to really look at that as something to set to ask some additional questions about and say, okay, it's nice that we've got a view on this, but is it really worthwhile for us to be writing that data to a physical location and having to update it every time we make a change to the underlying table? And the Halloween problem. So the Halloween problem is a topic that comes up later on in this, and it was actually a pretty decent stumbling block for this. I had read about the Halloween problem, I think, beforehand, but I had never actually seen it in the field. And fortunately, I got to ask Kevin Fiesel a question about that at the time, and so he may remember this. So we'll talk a bit about the Halloween problem and what the protections for it are like. So, with all that said, this case study is about a one specific procedure. So ChannelAdvisor does e-commerce, and a lot of this is, keeping track of what items a customer has for sale. And there's a lot to manage all the details about the item itself. And one of the things we track is the quantity for that. So this stored procedure is a procedure for updating the quantity of a given item. Now, each item can have multiple rows because it can have quantity in different distribution centers, and we track them all separately. So this stored procedure is updating multiple rows for the quantity for one given item. Uh, we do this by calling a stored procedure with a memory optimized table valued parameter. So we pass in what quantity we want to have for each distribution center, and we update rows in the underlying table. Typically not a ton, probably just a handful of records, possibly just one. But the
Hey,
updates are custom.
oh, sorry. Quick
Yes.
question that came in. Since you mentioned views just not too long ago, a question came in. What can you do with views in T-SQL?
Mainly, you would use a view to kind of predefine any query that you would want to frequently refer to. So that's the biggest thing for them is you can get information from multiple tables or even reference other views and put together a result set that you're going to refer to commonly. You can also do some things with security, like you can give people access to view the content, view the results from a view without giving them access to view data from the underlying tables. So it's useful for security purposes, but typically people just use it to basically predefine queries. And you can query against a view and add additional filters to it or whatever. So that's the main use for it. And typically, I wouldn't say you would want those to be indexed because it does add additional overhead when you index the view, because now we actually have a separate copy of the data that we're maintaining that is just the view. Anything else?
That sounds good.
Okay,
Yeah, I just like to call them saved queries. So yeah.
there's that. So the updates in the system are customer driven. So we have customers uploading information to us about things that they're selling, and we need to have those changes, especially for quantity, get into the database and be accurate and be very quick. When I started working on the stored procedure, it was taking 3.1 milliseconds on average. And all the numbers and stuff that uh, I'll give you about the time and the number of executions comes from Query Store. So we use that very heavily too. You might ask why I was tuning a stored procedure that runs in 3.1 milliseconds. Well, it's because when I started working on it, we were running at about 285 million times a day. And this is across dozens of servers and hundreds of databases running the same schema. But you can see under those circumstances, any improvement we can make is going to be multiplied many, many, many times. My original goal was, let's see if we can reduce the runtime of this thing by 1 millisecond. And that's where I started off. So the procedure does a few things. Unfortunately, I can't show you the actual code for the stored procedure because this is code that we're actually using. But I'm going to show you some anonymized plans, and I can tell you essentially what the stored procedure is doing. First, it populates a few variables, and the statement to do that isn't really a problem. Second, we check for item listings. So if we've got, say, 20 of a given item for sale, and we have 5 of them already up for sale on, say, eBay, on some marketplace. Well, we don't really have those 5 anymore. They're kind of spoken for. So there's a quick check here that looks for any current listings of the item we're updating, so it can subtract that quantity back out later. This does not take a considerable amount of time of the stored procedure, or didn't really at that time. Then it performs the update. This is the majority of the duration of the stored procedures, like 80% of the runtime, where it was when I started on it. So regardless of whatever else goes on and whatever improvements we can make, at some point I'm going to have to look at the update statement itself and see what we can get out of that. Then we insert missing rows. So this is an upsert procedure. So if we're trying to update 3 rows based on the information that's passed in, and we only update 2 rows, then probably the 3rd row doesn't exist and we need to insert it now. So we go and we try to insert the missing rows. And one of the things I learned during this that I wasn't aware of beforehand is that when you run the insert, even if it doesn't insert any rows, since there's a trigger on that table, we'll run the trigger anyway, even though we didn't insert anything. So that was an interesting piece for me. So here's the anonymized execution plan, or part of it, for my update statement. And there's a lot going on here. Actually, I'm going to pop over into Management Studio for a couple things first. So I mentioned that we were doing memory optimized table variables. I've got some examples here, and like I said, I can't show you the exact stored procedure, but I've got an example I want to run through with us later. And this is based on the AdventureWorks database. So I'm going to do a couple things right now. I've already restored the database, and what I'm going to do is create a file group that can contain memory optimized data, and I'm going to create one file to go in that file group. I'm also going to create a couple of data table variables. I'm going to create a couple of memory optimized table variables. One of them has product, quantity, unit, price, and you can see that the type that I'm creating is memory optimized. Second one has a few more fields. We're going to be using both of those. I'm also going to enable query store for the example that we're going to get to later so that we can see all the good numbers for it. So now let's look at this execution plan. So I've got the entire stored procedure here in an anonymized form. So let's take a look at my execution plan. So this thing is pretty huge. Now, earlier on, I said that there wasn't anything really obvious here. There weren't any table scans. There weren't any missing indexes for this. And you might actually notice there is an index scan here. Well, this is scanning a memory optimized table variable. So we're not even having to look for a physical object. We've already got this information in memory. And we are referencing it again here. And there's actually another memory optimized table variable here, although this one is just being seeked against. So we've got that. But those aren't really problematic. We're reading. You can also see the row counts here for almost all of these operations are either 1 or 2 or 0. So there's very small amount of work going on here in this stored procedure. So other things that catch my attention, there's a sort operation way over here, but we'll get to that in a moment. There's a table spool here and here. Because we're doing a full outer join, we're kind of reading data from one of the underlying tables and then using that same data a second time. This is more interesting though. This is against object 7, and this is my underlying table. This is the real physical table that we're trying to update. And it did get my attention, even as I wasn't seeing a lot here we could improve on. There's a lot of operators, but all of them are pretty cheap. We're only moving one row from here to there. It did get my attention here that we're referencing this table 3 times. And I always like to go after key lookups whenever I see them and see if I can get rid of the key lookups. But in this case, I couldn't figure out at first why we had 2 index seeks. We'll come back to that. So once we've joined everything together from our table variables, our memory optimized TVP, our other memory optimized table variable, and from the underlying table, we sort our results and we actually update our index. Now here, we do our clustered index update. Okay, cool. Now, what really got my attention at this point is I was like, huh, we have a table spool operator here. We're spooling it after we've already done the index update. All right. Okay, well, we're probably using that here and here. But what is all this work? We've got a sort operator and we've got another clustered index seek, and then we're sorting it again. And wait a minute, we're doing a clustered index update, but we've already updated the clustered index. I must admit, this took me a couple minutes to figure out what was going on. And what was interesting to me at that point was this. Our clustered index seek says view clustered. So we've already updated our physical table here in our clustered index update. We then spool off the results so that we can update our indexed view that's referencing the physical table. Now, this was kind of the first thing I thought of at this point for how we could improve this update statement. It's like, well, wait a minute. We're doing a lot of extra work here to update this indexed view. Okay, and cost is always an estimate, but the cost estimates here on this middle line is more than 50% of the cost of the query. So that got my attention. It was like, well, do we need to have an indexed view here? And I wasn't so much asking whether we need to get rid of the view, but I wondered if that view needed to be indexed, if it's going to cost us this much extra work. Um, One of the other things that did get my attention at this point is the clustered index update. Whenever you have like an update or an insert statement, typically the most expensive operation is the one that's actually writing the data. In our case, this operator is only costing us 22% of the cost of the plan. A lot of times I'll see this be much higher, be 70 or 80% of the overall statement. But here it's really small, which tells me there's just a lot going on in this statement. So those were my initial thoughts looking at that execution plan. And I came up with a few more after that. So my first thought was that table spool, that view, we could get rid of a lot of work if we were not, if we didn't have an indexed view to update every time we run this stored procedure couple 100 million times a day. Next, I thought the way this procedure is structured is we run the update statement every time through, and then afterwards, we try to run the insert statement every time. Well, a lot of the time, we're probably not going to need to insert anything. We've probably updated our rows. I mean, and logically, how many times do you insert a row? Well, only once. How many times do you update it? Infinitely. So I thought we really might be we're running this insert statement all the time, but it's probably not necessary. And it's also meaning we run the associated trigger hundreds of millions of times a day. What if we could do something to get rid of that? That sounds like a good idea. Um, we're using table variables, memory optimized table variables and TVPs multiple times through this. And my thought was, well, what if we change this to using a temp table? Could the temp table and the fact that it has statistics, might the optimizer come up with better execution plans in general, and we could get some improvement out of that? Seemed like an idea worth trying. And finally, the update statement itself. So getting back and looking at it, I wanted to see if I could get rid of the multiple references to the table, and I wanted to get rid of the key lookup on that table, both. So first things first, this one seemed easiest. So the indexed view requires a spool. It's pretty expensive from everything I'm seeing, even though that's estimates. Um, the DML operator looked very cheap by comparison to the rest of the execution plan, but I wanted to go and understand what the view was doing. So what the view is doing, as I've said, an item can have multiple rows. So one item could have 2 to 5 rows, probably the vast majority of the time. And what the view is just doing is just aggregating those 5 rows and giving us one number for quantity. Well, that seemed like a lot of work to do to ultimately allow us to read one row from the view instead of reading a handful of rows from the underlying table. And I didn't really have a good estimate for how much effort this would save us, but I went ahead and I removed the index since that's all it seemed to be doing for us. I removed the index on the view, I let the view remain. This reduced the runtime of the stored procedure by about 20%. It varies a bit here, but it depended on which day you were actually measuring from in Query Store. So we started off with a 20% reduction just from getting rid of that, which seemed like a really good start. So separately, and I did several of these changes, and I did them all separately, which I think was a really good idea because it allowed me to evaluate each one of them separately. So memory optimized table variables. So table variables get a lot of flack because they don't have statistics. Um, so I wanted to see what would happen if we replace the table variables with temp tables. The SQL Server optimizer always assumes that a table variable only has one row because there's no statistics for it to make a more accurate assessment. Temp tables have statistics. So I replaced all of the TVPs and table variables with temp tables, populated them, and then used them in the final statement. And the result was this was not a great idea. So the trade-off was, yeah, the optimizer has statistics, but we're creating the temp table in tempdb. In other cases, this might work really well, but in our case, we're now creating 3 or 4 additional temp tables in tempdb every execution, hundreds of millions of times a day. And that if you go and you look up tempdb contention, there's a lot of blog posts that people have written on the subject, and they'll frequently talk about enabling a trace flag or having additional files in tempdb so that it can kind of parallelize creating new objects in tempdb. What gets understated is create fewer objects in tempdb. That's kind of the best solution, I think. And in this case, changing this procedure to using temp tables was creating way too many objects in tempdb. So this change we actually reverted. And this my final thought on this is that memory optimized table variables are really hard to beat. If you're concerned about the execution plan that SQL Server generates when it's using a table variable and you're not using one of the later features from like Intelligent Query Processor in SQL 2019 and above, if you want to encourage it to have a specific execution plan, give it a hint. I've gotten a lot more positive on using hints, either using join hints or index hints in the last few years than I would have been previously. And part of it is because it does help sometimes in working with table variables. Any other questions so far, Kevin?
There was a question a couple of slides ago where Mark was asking 50%. So this was
50%
on
of
the execution plan slide.
Yeah, so yeah, the clustered index update for the view is like 11%. There's 2 sort operators that are 12% each, and the table spool is another 20%. I think the number is actually like 57% here, something like that. So, and by that I was talking about really this entire middle line and this guy right here. All of this is just supporting the indexed view. This is us, we're taking the table spool from the first line. This gives us the rows we're needing. We sort them. We have to check the index view to find those rows. We do some scalars. We sort the information a second time, which I love. And then we finally update the indexed view. So all of this is necessary just because we have an index built on that view.
All right, makes sense. Thank you.
So that was the 50%. Next. So this was actually a really easy improvement here. I figured that, so every time we run the stored procedure, we run the update statement and the insert. And the insert is there in case the row that we're trying to update doesn't exist yet. Fine. We'll update it many times, but we'll only ever insert it once. Now, if we insert 0 rows, we also run the trigger as well, which is even more work, or so it seems. Well, the logic to improve this and allow us to skip the insert statement entirely was pretty easy. If the TVP that's being passed in is 3 rows and our update statement updated 3 rows, then we don't need to insert anything. So this allowed me to put in a quick flow control around it, check the row counts, and if we've already updated everything, we don't even need to run the insert statement. The number of executions for this statement dropped from 350 million times a day to 6 million. Weirdly, though, the runtime for the stored procedure didn't change much. It went from 1.95 milliseconds to 1.91. This still amounted to 14,000 seconds of duration per day because we're running it so often. It also reduced trigger executions, and I think the trigger executions saved us another 16,000 seconds a day. I did figure out why this was such a small improvement. And what it is the insert statement, the execution plan it had, it was actually being really efficient. It was querying the underlying table, it was querying the table variable, joining and coming up with 0 rows. And part of that is the way that row mode statements, the way that SQL Server executes things in row mode. Once it gets to a point of realizing there's no rows, it can just pass 0. There's no data all the way up the rest of the execution plan, and very little work takes place after that. So the insert operator wasn't actually doing any work, and that would have been a lot more expensive. But so this ended up being a small benefit, but it was still a benefit. So we kept that change. Which it brings us back to the update statement, which was fairly complicated. So there was a lot going on here. There's actually 2 update statements in the stored procedure based on the input. We either run update A or update B, but they're mostly pretty similar. So one of the things I realized is we had a redundant aggregate in the common table expression. I mentioned earlier on we checked to look for existing listings for the item that we're trying to sell. So we go check listings and see how many how many instances of it are already for sale. We get that number so we can subtract it back out before we write in the database how many that we have available. Well, when we run that query, we get a number. We've aggregated that number, and we put that number in I believe in another memory optimized table variable. So when we're doing our update statement, the first thing we do is we read that memory optimized table variable that has our listings, and we sum up those numbers, which is kind of pointless because we've already aggregated them in the step earlier in the procedure. So we were summing it a second time, which didn't make sense. So when I realized that, we got to remove the first common table expression for the stored procedure. And yes, I did say the first one. There was a second common table expression. And the common table expression was referring to the base table. This is why we had 3 references to the table. The key lookup is easy enough, right? We used a non-clustered index, but it didn't have all of the information we needed, so we then had to hit the clustered index. Fine. The other index seek was coming from the common table expression. And the common table expression, we're reading the underlying table and we're applying some case logic to figure out, well, are we doing a relative update to our quantity? Are we just adding this to what's already there? Or are we just replacing what's already there with what was passed in? So there's some case logic there in the common table expression, and it returns some information. Well, we also do more case logic in the actual body of the update statement. So I basically took all the case logic and unified it into one set of case statements, and I got rid of the common table expression, which meant we didn't do a second lookup against the table. I have an example for that as well that I'll read through with you just in case that is confusing. But so for the key lookup, like I said, we're using a non-clustered index, and then we're looking at the clustered index to get some additional columns out of it. So I looked at our 2 indexes because it sounded like it'd be better if we maybe, what I typically do with key lookups is maybe I'll add another column to the non-clustered index so we don't have to do the key lookup. And the non-clustered index was looking up our item ID, our account ID, and our distribution center ID. And the primary key, the clustered index, was based on our item ID, our account ID, and our distribution center ID. The first 3 columns were the same. So we could just as easily be using the clustered primary key directly instead of using a non-clustered index and then having to do a key lookup or having to add other columns to the non-clustered index. So since they were doing basically the same thing, I added a hint to the statement and had it use the clustered primary key to begin with. So by getting rid of the common table expression and getting rid of the key lookup, now we had one reference to the table, and this reduced our runtime by another 28%, almost half a millisecond. And that saved us 189,000 seconds per day, which was a lot more satisfying than the previous one. So here's the execution plan we had afterwards. Getting rid of the common table expressions, rewriting the logic a bit, and adding an index hint so we only used So we only used one index seek against the physical table. And note this, the clustered index update is now 73% of the cost of this statement instead of 22%. The index update didn't get more expensive. The rest of the statement got less expensive. So at this point, we had reduced the runtime of the procedure from 3.1 milliseconds to 1.4. And so we had gone well beyond what I'd hoped. I'd been trying to get this reduced by 1 millisecond. But I had another idea at this point. Similar to the idea that we have a lot of unnecessary inserts, we probably have a lot of unnecessary updates. I did mention earlier that the behavior here is driven by the customers. So they're uploading information to us with what values to update quantity to for all of their items. And a lot of times, we know this from the inventory side and the updates to the other information about the items. A lot of times they're just uploading the same information over and over again. It's redundant. They're going to upload the same numbers to us maybe every hour, maybe less often, maybe more. Well, what if they are telling us to just set the quantity for this item to the same value and nothing has changed? Seems like we could be doing a lot of extra work for no reason. So I thought, what if we could limit the updates and only write the record back out when we actually need to? The logic for that seems fairly simple. Hey, why don't we just put a where clause on this and say, sure, let's update this, but only if the old quantity isn't equal to the new quantity. So we tried that out, and it was a terrible idea. So at this point, we ran into something called the Halloween problem. And the stored procedure actually started taking significantly longer with me adding that where clause, telling it to write less data. I was actually rather confused, and I went to Kevin with this because I was looking at the execution plan and I couldn't figure out why there's another table spool in my execution plan all of a sudden. And what Kevin said was, well, what you're describing sounds like the Halloween problem. So in my slide deck here, I've got a link to it, and I will tell you where to get the slide deck itself later on if you are interested. So I went to go read about this, and the Halloween problem is something that it's not a SQL Server problem, it's a database management problem. And it was identified by some IBM engineers in like the late 70s. There's actually a Wikipedia page for the Halloween problem. So this can affect any DML statements, inserts, updates, deletes, merges. And the gist of it is if you are trying to change the thing that you are querying, then you can run into the Halloween problem. What really happens is it's possible for you to say update a given row, have that row move in the index that you're working on. But if SQL Server is operating in row by row mode, it can read that row a second time and try to update it again. And when I say SQL, any database management system could have this. So the Halloween problem is it's possible for you to try to operate on the same row multiple times. That's bad. And this was a prime example of it because I'm trying to update the quantity, but my where clause is referencing quantity as well. So that's a thing to look out for. Um, so SQL Server doesn't let the Halloween problem happen. It puts protections in place, and the protections typically are a blocking operator, like a sort or an eager spool specifically. Um, and so it changes the execution plan and it inserts this blocking operator to stop us from operating in kind of row by row fashion. The blocking operator is going to tell SQL Server to take, wherever it's reading the rows from, read up all of those rows and give them to me all at one time. I'll sort them, I'll table spool them, I'll do whatever. But I'm going to force you to give me all of the rows and then I'll go and start updating them. Really, it's SQL Server's trying to separate the reading side from this query from the updating side from this query. And it's bad for performance. In this case, the stored procedure was taking 60% longer with that where clause on it. So, but it still seemed like a good idea. So we came up with another approach. My thought was this, and um, I've got some other links in here as well. There's some links to blog posts by Paul White, and Paul White has something like a doctoral dissertation on the Halloween problem. He has 4 really detailed blog posts. I have a shorter one because I didn't feel like reinventing the wheel. And I've actually pinged him briefly about this. My thought was, since SQL Server is kind of trying to separate the read from the write, what if I completely separated them? What if I split the operation? Let me just run a query, just run a select statement, select all the data that we need and stash it. Well, not in a temp table because that would be terrible. But what if I stashed it in a memory optimized table variable? I can do all the math, do all the case logic, and I can know at that point what the new quantity is and what the old quantity was. And I can put that in a memory optimized table variable. Then I can check the results separately. And if the quantity doesn't change, I don't even run the update statement. I also had to change the logic for my inserts because whether we run an insert or not was based on row count for the update statement. So before, if 3 rows were passed in our TVP, if we updated 3 rows, we didn't need to do the insert. Now we get 3 rows passed in, we might not update any anyway. So I changed the logic for the insert and to do a query about doing a left join between the table variable and the TVP and use logic based around that instead of using the row counts. One of my concerns was I didn't know how much overhead we were going to add to the problem because now we have a query that is populating the table variable. We have another query that is reading the table variable and then doing flow control to decide if we need to run the update or not. And then we actually run the update, at least some portion of the time. Populating the table variable, so running the query and writing that data into a memory optimized table variable took between 90 and 100 microseconds. And this is really granular, but Query Store gives us information down to the microsecond. Checking the results and doing flow control took 10 to 20 microseconds. And I didn't know how often we were going to be skipping the updates, but we started skipping the update statement completely 96% of the time. At which point, the stored procedure was taking 320 microseconds, so almost a 90% drop from where we started off, which called for a victory dance in my mind. So, and I've got a few more things I want to get to, but let me go to my examples in Management Studio. So I've set up a stored procedure here, and I've restored the database. I've added in some table variables. We've got Query Store enabled. All right. So here's a stored procedure I wrote, and this is similar to the update procedure, the upsert procedure that I was working on. But this is based on AdventureWorks 2014. So I'm looking for a specific sales order ID, and I'm passing in some update information in a TVP that is memory optimized. So this is like the stored procedure when I started off. So we run a simple query here, and then we either do a relative update and we add quantity numbers to what's in the table, or yeah, this is slightly different. So if we're doing a relative update, then what we do is we update anything in the sales order detail table for this order based on what's provided in the TVP. And we will just overwrite the quantity, the unit price, and update the modified date based on what's passed in our TVP. There's also an absolute update here, and this also updates the physical table. But if there is something in the underlying table that doesn't appear in the TVP, then we'll delete that record from the underlying table. Also, there's an insert statement. So if the information in our TVP includes a product ID that's not in the physical table, well, then we'll insert it. So we might be doing an update. We might be doing an update and a delete. We might be doing an insert, or well, the way this is written, we'll be doing an insert every time. So let me complete that. Okay, so that's our first stored procedure. Here's our second stored procedure. Now this was written with more of the with the same approach of taking the information and putting it in a table variable and then deciding whether we need to update or insert or delete everything. So here, instead of just going in and doing an insert, we select the information from the TVP and the underlying table, and we write this into the detail changes memory optimized table variable. Then we run a query and we say, okay, here's our changes. Is the order quantity different between the current and the new, or is the unit price different between the current and the new? If there is a change, then we'll run the update. And the second logic, so if we are doing a full update between the two, this will allow us to do a delete potentially against the physical table. So if we've got something that's in the TVP, or sorry, if we've got something that is null in the TVP, but exists in the physical table, well, we're calling it without that in the TVP, so we don't want that to be in the order anymore. So in that case, we'll run the delete statement. What if, and the other option is, if something exists in the TVP, but it's null in the table, then we need to insert it. And in each of these cases, if the given product is in both, then if there's nothing in the TVP that's missing from the underlying table, we don't need to run the insert. So we'll fail this check and we won't even run the insert statement. So this script, what I'm going to do is I'm going to query the information for one specific order. I'm going to stash this in my table variable here. I'm going to print it out. And I'm going to run both procedures. And in both procedure calls, and I'm going to roll back just for safety's sake afterwards. But in each of these calls, I'm just giving it the information that already exists in the database. So we will see what that looks like. And this is a query against query store to get the details for both of these stored procedures in the last 30 minutes. All right, let me make this a little easier to read. So here's my first stored procedure, detail update. And we've got multiple statements inside of it. So here's our delete. Here's our insert. And here's our update. So average duration. My delete is taking 95 microseconds. That's not bad. My insert is taking 131 microseconds. The update is taking 15 milliseconds. That's rather a lot. So here's the modified version. What you'll see is that you don't actually see the execution in the text here. You don't actually see an insert, an update, or a delete. Okay, there's an insert into our table variable, but not into the base table. Well, based on the logic here, if the existing item is null, then we're going to be inserting one. So this is actually our insert statement right here. And that is taking 12 microseconds. Previously, it was taking 131. That's pretty good. This, if the new data passed in our TVP is null, then we're going to delete the existing record for that product out of our base table. That's taking 11 microseconds instead of 95. But the big difference is this: when we detect that there's a change for a given product, then we would run our update statement. So we're not seeing the update because we just ran this check and decided it was unnecessary. And this took 17 microseconds instead of 15 milliseconds. So this is essentially what I did in updating the stored procedure. And going back, there was one more thought here. So I mentioned the idea of separating the query, the reading of the data versus the writing of the data. I actually I wasn't the first person to come up with this. Paul White had mentioned that in one of his blogs about the Halloween problem like 5 years before, and he referred to it as manual Halloween protections, which is a good term for it. So I like that one. But that's what I'm doing is I essentially put in Halloween protections in place of SQL Server, but allowing me to do that means I can decide when I want to do these DML operations or not. One more thing. So I found from this example, it's a little odd sometimes. If I run this, if I run these stored procedures more often, I find that the more I run it, the lower the average comes down on this update statement. So if I keep running this, let me see, did I run this? I ran this how many times? Oh, I ran this 10 times. If I run this, 50, 100, several hundred times, I find that the average of it kept coming down. So one afternoon I kept running it, and I found that the runtime of it got down to around 2 milliseconds. And so I tried to figure from that, okay, how often would we need to skip a redundant operation for this to be worthwhile? And I started with these numbers. My update was taking 2 milliseconds. The queries to populate and check the table variable was taking around 70 microseconds. And I did a little algebra over here, and the answer is 3.5% of the time. If you skip the update 3.5% of the time for this case, it becomes worthwhile to have the extra logic and the extra overhead. If you're skipping a redundant operation more than that, it could be a really big win. And I've used this approach in other places since then, usually to really nice effect to stop us from doing DML operations when we're just writing the same data over and over again. Any questions?
So there was a question that I was holding here until the end to see if you were going to be able to cover it, but um, do you have any examples of the stored procedures? Obviously not the real one, but anything ginned up that you might be able to walk someone through in terms of procedure text and not execution plan?
Well, okay. Let me throw this out then. I actually have a GitHub link for the presentation slides and examples. What I would say is, first, this example that I've got here in script 11 and 12. This shows the difference between the two and kind of the checks I'm using to decide, do we need to do an insert? Do we need to do an update? So you could look at this as an example, and I can follow up with questions on somebody if they want to look at this and ask me any questions they might have about it. Now my slide deck are up at GitHub. If you go to github.com/SQLJared, I have my slides and my example scripts for this presentation. And so you can take that and actually look at it and look at the stored procedure and see how it works. And this is based on AdventureWorks 2014, which is an available database from Microsoft. So if you want to look at the code and how I wrote this, that would be the example that I have for you. Any other questions? There is
So
one more.
oh,
Go
go ahead,
ahead.
Jared.
No, go ahead.
Oh, I was just going to try to gin up some questions for you by saying that if you do have questions, chat, get them in. That way I'll be able to ask them, and we'll be able to pick Jared's brain a little bit, but get them in chat.
So let me see. Let me just make sure SQL. No. Is GitHub. Yeah, okay. GitHub.com/SQLJared. Just making sure it wasn't more complicated than that. I had one more example. And what it was from is just to make something a little more concrete. I had talked about the update and saying that there were multiple common table expressions at it, and one of them just had case logic that was redundant. Here's an example, just in case that wasn't clear. So here's a common table expression that's joining between a table variable updates and the sales order detail table. And I've got some case logic where I'm saying, okay, based on if any of these are null, then give me this value versus giving me that value. Okay, cool. And that gives us a result set. And then we have an update statement that is joining to that common table expression, and then joining to our physical tables and applying some more case logic. This is like what I encountered in the actual update statement. So what I did was I rewrote it. I took all the case logic from here and from here, and I combined it. And so now I have one reference to sales order detail in my actual final query instead of 2 references to sales order detail, which resulted in separate seeks. So this is how I got rid of one of the seeks against my base table. So that was one of the things that helped improve our performance. If you're more interested in the Halloween problem, I've got a link in my slide deck to Paul White's posts about it. He had like 4 separate blog posts in sequence, and they're from 2013, but they still apply. Aaron Bertrand had a really good post about upsert coding patterns, which had some things that I was not aware of in terms of how you can optimize upserts in general. This is kind of a specialized offshoot of one of the types that he identifies. But I came across this after I had done this work. But if you see these kinds of, if you work with upsert procedures in other cases, this is a good thing to refer to and just see some of the suggestions and optimizations that he has on it. I have my own blog, and I have posts on the Halloween problem and blocking operators, which is actually the first thing I blogged about, and this topic, so the work on optimizing this stored procedure. If you're not familiar with TVPs or memory optimized table variables, I've got links to just the Microsoft documentation on that. I've also got a link to GitHub. The QDS toolbox is something that was released by a couple of our colleagues at ChannelAdvisor. If you're not very familiar with query store, you might want to look at the QDS toolbox. You can download that. There's some useful procedures, things that you can very easily turn into tools for you, and you can use that as a way of getting more familiar with using query store. I also have a link to the presentation slides and examples. For this presentation, every millisecond counts, which is hard for you to click on until you've already downloaded the slides and examples. But, and if you have any questions, feel free to @ me or check out my blog and see some of my other posts. But that is everything in a nutshell.
All right, thank you. So one more question did come in, and that is, did you happen to test using the SQL merge statement?
No. I'll say this, I like merge statements. I like programmatically being able to write a statement that either does the insert or the update or delete. I really like how that functions as code. I don't like how it functions as execution plans. I don't think there's as many levers for me to pull on to improve a merge statement that's running suboptimally. And the idea that behind the scenes, it is always trying to do an insert and an update and a delete at some level, even if there's no, there's no actual part of the merge statement that say is deleting records. It still has some runtime that attempts to do that. I've used merge statements before. We've still got them in places. But for the most part, I've decided to not use those.
Yeah, I dropped a link in chat to Aaron Bertrand's article about all of the bugs that are in the merge operator that will never be fixed.
That's the other thing. There's a lot of them, and I'm sure there are a lot of things that they have fixed for merge statements, but it's always been a bit clunky in that regard. There were a lot of bugs associated with the merge statement. Like I said, we're still using it in some places. In some places, it's just programmatically, it's really helpful. But when it comes down to something that I want to perform, I'm probably not going to write it as a merge statement. And that's without us even running into the bugs. And yes, there are numerous.
Sad but true, yes.
Sad but
so if there are any other questions, let's get them in chat. And just so I have an opportunity to let people put questions in chat. By the way, if you do have one, really good idea would be to say something like, got a question? And that way I know you have a question so that I know that I should be vamping for a little bit while you type out the question. So you don't have to type out the entire question right now, and then right when we're ready to close, you're trying to slide in there like Indiana Jones going under the rock wall. So we don't always have to end in a dramatic manner like that. But in case there are no other questions, I do want to mention, remember everybody, that next Tuesday we have our business intelligence and data science meetup. So that's our fourth Tuesday of the month. Third meeting of the month is what I was originally going to say. And Armando Lacerda is going to talk to us about the serverless SQL pool in Azure Synapse Analytics and a little bit of data lake ideas. So hope to see you there. In the meantime, thank you, Jared, for a great presentation, really digging into a difficult problem.
Thank you for having me. I hope everybody enjoyed it.
Absolutely. And as we wrap up for tonight, if we see you next Tuesday, excellent. If not, until we meet again, everyone, take care.